Okay. They have a specific way that they get done. Okay. And a lot of people call this the FOIL method. Some people have issues with the FOIL method because some people just don't get it. Okay. And you follow this when you do it though. Okay. And what it is for the F, it stands for first. Okay. The O stands for the outside. Then this stands for the inside. And then the L stands for last. Okay. So when you have two binomials, okay, basically think about it in this way. You have an A plus a B and an A plus a B. And what you're doing is they're multiplying because you have the multiplying in between. Okay. And so where do they get the first? What's the outside? What's the inside? What's the last? Okay. They each have their own thing. So in each of these, your first one is your first. So these are your first. So you would multiply those. Okay. Then you have what's called your outside when you look at both. That means they're the furthest out. So here's an outside one. This is an outside one. Okay. So next it says to do your inside. That means these two, being that they're inside of both of them, are your insides. Okay. And last, being the ones that are listed last in each separate binomial. So here's a last, here's a last. Okay, so now that we've identified all these pieces, let's look and see what it looks like. So like I could do with this. So like it says first, so I'm going to do A times A, which we know will be A. And since there's 1 and we're multiplying exponents, that means you add them. So this becomes A squared. Okay, then it says we do outside. So your outside being your last pieces. So it becomes plus AB. Then it says do inside, which again is AB. Then it says to do the last, which, look in here, this one is last, this one is last. So then that becomes B squared because they each have 1, and you add together your exponents. Then you put together your like terms. A squared doesn't stay. Now I got a 1AB and a 1AB, so it becomes plus 2AB. And then just drop your B squared. Okay, this formula will become important as we move on with things. Okay, so now let's see how that looks when we have numbers. Okay, so going back to this problem here, where I have x plus 3 and x plus 2. Okay, so the first thing, we do our first. The x is the first in this one, this x is the first in this one. So I'm going to multiply those. Okay, remember they each have an exponent of 1 even though it's not written there. So that one becomes x squared. Okay, next we do our outside. So it's this x here with this 2 on the end. So it's kind of like distributing, but in a little different fashion. So this is going to become plus 2x. So I've done my first, I've done my outside. Now I'm going to pull my insides. That means these two here. So I'm going to put the 3 and the x. So that one becomes plus 3x. Okay, and last is our last numbers. So the ones that are listed last in each binomial. So the 3 is listed in this one, 2 is listed in this one. So I'm going to take this and I'm going to multiply those. So 3 times 2 is plus 6. Okay, it's a good thing. All positive numbers makes our life a tad bit easier. Okay, so once again, like we did up at the top when we just put the letters together, going to combine our like terms. Our middle is our like terms. They both only have an x. So we're back to adding the polynomials, which we've done for the last few days. Okay, so put those together. I got x squared plus 2 plus 3 is 5x, and then just drop the 6. There is our final answer there. Okay, not as bad as it looks. Okay, so let's try another one. Okay, so I have x plus 2 and x minus 5. So start doing the FOIL method, even though some teachers frown upon it. So we're going to do our first, which is our x and our x. So x squared again. We're going to do our outside pieces. So this is the outside, this is the outside. So this becomes an x times a negative 5. So it becomes negative 5x. Next is the inside, which is, start here is the inside piece, to this x. So this becomes plus 2x. Once again, it's positive because I did positive 2 times positive x, so it's still a positive at 2x. And then I'm going to do, last but not least, the last ones in each binomial. So last is 2, last is here's negative 5, so 2 times negative 5, negative 10. Once again, we need to put together our like terms. Here in the middle, so I have x squared. So a negative 5 plus a 2 is a negative 3x, and then just drop the negative 10. Okay, completely solved, all simplified. So this one is done. Okay, so not so bad yet. Okay, so let's look at, you will see some that look like this. So I have x minus 3, and it's to the power of 2 or squared, which means I have 2 of those. So it's going to look like this. I'm going to have x minus 3, and since there's 2 of them, there's an x minus 3. So this became a binomial times a binomial. So once again, go through that FOIL method, multiply your first. So it's x squared. Multiply your outside pieces. So an x times a negative 3 is a negative 3x. Then we're going to do our inside pieces, which in this case becomes another negative 3x. And then our last pieces is a negative 3 times a negative 3. And a negative times a negative means a positive. So plus 9. Okay. Once again, combine like terms in the middle. It's a negative 6x because a negative minus a negative makes it a bigger negative. Drop down the x squared, no one to pair it with. Drop down the plus 9, nothing to pair it with. And I'm also hoping you guys have noticed all of these have been written in that standard form where they go from the highest exponent to the least exponent and then left with the constant at the end. The constant being the one that doesn't have a variable with it. Okay, that's what a constant is in case you forgot. All right. So we've done a bunch, guys, and I know this has been long. But now let's look. We have what's called a binomial by a trinomial. Okay. Yeah, there's some work to these guys, and I'm sorry, but there is. But I don't feel like it's nothing you all cannot handle. Okay. And it's going to be kind of like that distribution. Okay. And a little bit kind of like those binomials. What's going to happen here is that this x is going to distribute to each piece. But then so is this too. Okay, so that means all these pieces are being multiplied. So I'm having, and I'm going to write it out, and I know it's going to seem tedious and a lot, guys. But this way you can all visibly see this. So I'm going to take this x, and I know I got to do x. And then I'm going to times it by x squared minus 5x plus 4. Then I'm going to take this 2. I know I got to do it times everything in there too. And no, you guys do not have to write it out like this when you do it. Once again, I'm just kind of trying to show all those pieces so you guys see where it's all coming from. Okay, so like I said, I'm going to do x times this, and this is an x to the first. So it becomes, since I'm multiplying, and this is distribution, but nicely since that one's got a 1 on the outside, these get multiplied, so it's x to the second power. Okay, now I'm going to do the x times the negative 5x, and since one negative, one positive, it's still the negative 5. Distributing into this, just multiply 1 times 1, so it's to the 1 power. And now I'm going to do the x times the 4, and it becomes plus 4x. Now I'm kind of getting to those adding polynomials a little bit here. So I'm going to add these together. Okay, first, though, got to finish all this. So distribute this, becomes 2x squared. Distribute the 2 to the negative 5, so it becomes negative 10x. Then distribute the 2 to the 4, so that becomes plus 8. Okay, so going back to adding up those polynomials, because here's another part, right? So look at what's the same. Okay, so I'm looking here. I have an x squared, because remember, you got to put them together by their same exponent. Okay, so here we've got the x squared. It'll go with the 2x squared. Remember, it's the same thing as having a 1. So I have a 1x squared. Okay, so I've used that one. I got a negative 5x to the first power, which would be the same thing here. So negative 5x to the first. And a 4x, but I don't have a 4x here. Ugh. Okay, so I'm going to put it out here on the outside for right now. And then I don't have a constant, and up here I don't have just an x. Yeah, sorry, running out of room. So go ahead, put your pieces together. I've got a 2 and a 1, so this becomes 3x squared. Remember, adding polynomials, the exponent stays the same. So I've got a negative 10 minus 5 becomes a bigger negative, so negative 15x. I don't have to put the 1 there, but if I want to, I can. Nothing, 0, so plus 8, and then plus 4. Now, if I wanted this in standard form, ooh, wait. I could put the 4 and the 5 to get 15 together, can't I? So I'm going to go over here and write that answer. But I see I've got a negative 15x and a 4x. So negative 15 plus 4 would be 11. So I've got, my final answer would be 11 squared. Then I'm going to put the plus 11x, because once again, I'm trying to get it in standard form, plus 8. So there's that one finished up. That's how you would write that one out. Because remember, put together your like terms. Can't forget those. All right. We're going to end it there because we've had a lot of work. Okay.